This is the first video in the AWS Developer Series. In this video we look at how we can run a Lambda function test for a Golang runtime using a tool called Lambda Docker. This is the GitHub link to the Lambda Docker tool. You can browse through the code, you can see it's actively maintained, and you can read up on all the important details about the lambdaci Lambda Docker tool at that GitHub link. Another important tool we use is Localstack. We run Localstack in a Docker container. This is an overview of the containers we've got set up and how they talk to each other. We have a Localstack container running S3. We have a Lambda function written in Golang running in a lambdaci Docker-Lambda Golang container. This is the Docker file we use for the Golang container. You can get the Docker file from the lambdaci Docker GitHub. This is a multi-stage Docker file. In the first stage, we build the Golang runtime and its dependencies. In the second stage, we copy our compiled Golang binary for the Lambda function to the var task directory in the image. Just a few details about Docker networking. So we have two containers, our Golang function container and our Localstack container. They will communicate via a custom Docker network that we set up in the Docker compose file for the Localstack container. In this file, we create a custom network called backend. Now this container is running in a folder called godev, and there's a naming scheme, which is the name of the folder underscore the name of the network defined in the Docker compose file. Now that we understand this naming scheme, we can always inspect this network with the inspect command. There are other ways to find the networks to know the way Docker is setting it up is good. So once we run the inspect command, we will get blocks of JSON. We look for the containers block and we can find the IP for Localstack there. We can use this IP as an environment variable in the docker run command, or we can just hard code it. Because we're constantly building a container and running the test, it can be easy just to hard code it. This is the command to build a container, and this is the command to run the container. We have a Docker file to build the image to run as a container. We have a Docker compose file for Localstack. To set up for the test, we first boot up Localstack, which mocks S3 for us. We get our network information. We run network ls and we will see the network defined as the scheme described. When we run the inspect command on a network, we can go through the JSON to find the containers block to get the IP for Localstack. Now we can hard code this in the code when we build and run the container. That's the next step for setting up our test to build this container using the Docker file in the directory, and we just simply tag it with 1. So we've built it successfully and tagged it. Now that we've built the container, the next step is to run it with the Docker command we described as before. And this is the output. So we've passed the input, we read the input to the Lambda function correctly, and then we process the input and push the data to S3. We could see that Localstack has updated with the output saying that the example bucket was created successfully. So everything worked out, our task worked. You can find the source code for everything at this GitHub link. You can find container code, Docker file and the Docker compose, and you can find the code for the handler function, which is using Golang modules. We have a main Go file where we will find SDK imports. For our handler function, we are using the S3 client. So we're using SDK code for Lambda and S3. And we just use typical S3 code. It's very simple. The Docker-Lambda supports many Lambda runtimes. When you work with Localstack and different Lambda runtimes, you can often run into many issues. By running the code in a separate Docker-Lambda container, this can really simplify debugging and solving these issues. Docker-Lambda is a great tool for testing Lambda, and it's really easy and simple to set it up with Localstack.